Okay, in the previous video clip we estimated, well, we had already estimated linest, the Greenspan reaction function, using linest, and then we ran the same reaction function in R. We have slightly different estimation, and that then begs the question, is there estimation issues involved with either of the software? Why the discrepancy between the variables yet so close? So the 1.4985 very similar, the 0.473 very similar to the beta 2 coefficient. So why the difference? One explanation here might be in the way we set up our data file. So let's take what we have here and just copy into a new worksheet. So we'll say insert new worksheet, and I would say same as before, Taylor rule, Greenspan, and I'll say update, and I'll just paste whatever I have here. I'll just paste in directly, should be fine. And maybe as we did before, we'll freeze the first couple of panes here. So view, freeze panes, and let's unfreeze that, unfreeze, and try one more time. So freeze panes, and then just go down to where we have our estimation, and you can see again slight discrepancy. Okay, so could be, if we look at our CSV file, so our Greenspan data, okay, here it's 0.725 all the way 39. When we go into our R and double click, if we take the first value here, copy, and go back and paste, it's 0.725, so 725,242. So it's rounded at this point here. And important issue here is when we're saving our file, so perhaps we should save this data again and bring it out to the maximum number of places in terms of the decimal. So let's remove this for a second, and file, save as, Greenspan, and I'll say 2. So as our second attempt, save, and then go back into R and go back to our program, and take the data again and adding that too, so it reads this new file here. So Greenspan and saved, and what I've done is just made visible to R the full set of the full higher numbers with a higher level of accuracy for the growth gap. Okay, so okay, and likewise we should do similar for here. So let's take these values and also okay, and these values seem to be quite just 2 decimal places. Okay, so we'll see why that becomes important in a second, and we'll save. And we've still saved that Greenspan data 2, and yes. And now, what I'll do is I'll press Control Alt Delete, and I'll close down RStudio, and don't save. And now, so I've closed down RStudio, and I'll go back, open it back up, and it brings up the file that we had initially. So let's just give it a bit more space to read. And I said I want to change the data here. So we're going to read the file that now is called Greenspan data 2. And I'm going to call this my data Taylor 1 to avoid any conflicts. And see if I can find any additional references to my data Taylor, and there is one just here. Okay, so let's put that in and we'll save. And that looks fine, so let's see if that works. Let's run. And the data's gone in. Attach Taylor 1, and let's just set up Y and X1. So I'll run those as well. Run, and do a summary. And it seems to be fine. Summary, correlation, and then we'll come down and make the regression estimate. Okay, so we're regressing inflation and output gap or growth gap onto Fed funds. So let's run that and check the values. And the values that we have here, let's just give ourselves a bit more space. So the coefficient output that I'm getting is as follows. Let's copy that, bring back into our spreadsheet, and make the comparison. Now the old regression, there was quite a bit of discrepancy between the coefficient values, or some discrepancy between the coefficient values. Let's just check this new regression. And now we're 362, that looks fine. 1511, that looks fine with rounding. And 4688, that looks fine. The standard errors are in line. 5578, 1754, 1397. Now R squared, if we can check, is the 5011. So this is our R squared. And the F statistic, let's have a look at F, is 3717, so same as here. So point to note, and important when using R, we have to be careful how we treat our data. When we read when we copy and paste data into a file, small discrepancies, right? When we save the CSV, the Excel file in CSV format, part of the motivation is to minimize the amount of memory being stored up. If you don't make explicit that the higher level of accuracy on the number, if you round to 3 decimal places, even just by making the number less visible, as what I'm doing now, this type of rounding, CSV will just take what's visible. Okay, and those small discrepancies in terms of the raw data, when read into R, produce fairly substantial differences in terms, well, substantial, perhaps not substantial, but noticeably different results. So if we take the original data, where we didn't make visible the full number accuracy, and compare the coefficient estimates that we get from R against when we make those numbers visible when saving the CSV format, there is some small differences that occur. Okay, what we got here second time round is in line with linest. So sometimes when making these type of estimations, there is no harm in running the linest estimator on the data available in the spreadsheet, and then verify the results in R. And if there are discrepancies, sometimes those discrepancies actually occur in terms of your data management, how you save your CSV file, to what degree you make explicit in the CSV file. If we round like that, that's what R will, once you save that in the CSV format, that's what R will read. And it's important that you make explicit the full accuracy of the number. Likewise, same with inflation. Now, I will save these files up to the OneDrive and make them accessible in the links below the video.